All right, so let's go ahead and finish this one, this 10.3. This is a really short section. Um, so it just finishes up on our data, okay? So let me get into the PowerPoint so you can see it here. Whoops. Share my screen. All right, so here's my PowerPoint. And I want to be able to click on this. Where's that here? Here we go. All right, so finishing data and a little other information. We're going to talk a little about line graphs. You guys probably already know how to deal with line graphs. Scatter plots, relationship between variables on a scatter plot. We'll talk about that. Trend lines and different types of association and how to choose the different types. So you've all seen a line graph, okay? It basically shows things over time. Time is usually marked on the horizontal. We talked about that the other day, with the variable being considered marked on the vertical axis, all right? So time horizontally, everything you're trying to tell about is vertically, okay? Consecutive data points are connected by line segments. So if you notice here, we have, here's your age in years, this is your time, and what they're trying to decide is what's the weight over 10 years, okay? So notice the first year has a weight, okay? And we use a line graph sometimes to show continuous growth. Okay, so after year one, they go from about 8 to almost 20 pounds. And so there would be some growth in, or the adding of the weight in that time. So you would have that depiction by this straight line, this, I guess just that line connection segments. Okay, says this is the first example of a depiction of continuous data. Okay, you can't just jump from 30 pounds to 50 pounds. You've got to continuously grow that throughout the year. Okay, and that's why we would use a line graph. Okay, what we have been seeing is just what's called discrete data. Okay, and in discrete data, we'll just have dots a lot of times. Okay, and it goes from one straight to the next thing, or just there's not a continuous of growth. Okay, um, you ask a bunch of people questions, you're going to go from one to another. It's not going to have 2.5. To be able to have a line graph, you'd have to have a weight of 20.3 pounds and 22 pounds and 28.7 pounds. Okay, that's how you would connect them there. Okay, now here's one of the things that we'd like to talk about is how we abuse statistics. Okay, weirdly enough, this is a graph, the same information in both. Okay, the number of graduates of community college. Okay, number of graduates in community college. The number of the graduates on this side, the years. Okay, and how it would grow. Okay, now how is this being skewed? The biggest thing is this one would be one you probably don't want to show. Well, it depends on what you're talking about. If you want to show that, hey, you're continually about the same number of students, this is the one you're going to show. And this one shows, wow, we're really getting better, bigger, 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 and then all of a sudden we have a fall off. Okay, now your boss, the board of regents, might want to know why is there this drastic fall off on the number of students. Okay, they might want to show this that it's very, very gradual. Okay, we had a meeting about at school, and they were using statistics to show how Fort Bend can pass a bond because their tax rate's not so high. And they compared it to everybody else, and they used a bar graph. And they skewed it so much that it made it look like, well, we're so much lower than everybody else when it was really a very small difference. They just showed the difference in a very exaggerated graph. They used a bar graph. This is exaggerating using a line graph. All right, so now using some discrete information, you have what's known as a scatter plot. Okay, now sometimes the relationship between variables cannot be depicted by even a broken line, so a scatter plot's used. Okay, this is an example of a scatter plot. Okay, hours of study and quiz score. Okay, I can't connect the score from 1 to 2 because you can't get a 1.5 maybe. You can either get one answer right or two answers right. Okay, You get 3 answers right or 9 answers right. You can't connect the 9 and the 3 together. So you can't connect them with the dot. Okay? This scatter plot shows the relationship between the number of hours studied and the quiz score. The highest score is a 10 and the lowest score is a 1. Okay? So these are just everybody's score. Now, what do you notice? Notice a lot of people that studied 5 hours had different scores. Okay, right down the middle. Okay? Lower number of hours, lower grade. Higher number of hours, higher grade, right? That's how it's supposed to work. That's what you're supposed to tell your students, right? The more you study, the better you get. Well, maybe not reference. I mean, you get some studying done, you'll get a decent grade, right? Now, through a scatter plot, we get what's known as a trend line. And this trend line, okay, gives this has already been put in here for, okay? And this is going to give kind of an average. A lot of times, this is not probably a very good trend line. I'd probably send the trend line a little bit lower because really you're supposed to have as many as the same number of dots on one side as you do the other. Says a trend line is a line that is closely fit to the data and can be used to describe it, okay? So how do I use this trend line to describe scores? The more you study, probably the better your score is going to be, okay? Trend line can make it used to make predictions, okay? Now it says if the trend line slopes up, okay, this is an example of a positive association, okay? The trend is rising, okay? From left to right, it's rising, okay? It's kind of a positive slope, and that's what gives you a positive association. If the points are going down or trending down, you have a negative association, and they give all this definition for this, but this is your negative association here, okay? So, and then if there's no kind of trend going up or trend down, and the dots are all over the place like this, there's no trend. You can't tell if it's going up or going down. This is what's known as no association. It says if the points do not approximately fall about any line, you can't get a trend line anywhere. You can't make a prediction. Information's all over the place, so there is no association. All right, then we have multiple line graphs used together to demonstrate different sets of data and comparison. So here is a multiple line graph. Okay, you can have as many as you want. Now, to do that, you still have your title. You still have this over here. Line graph still has to have your time. They have to have some connection, but you have to give a legend to tell which one's which. In this case, it's blue. Sometimes they'll use a symbol. Okay, so here's your red and here's your blue. It says this graph shows the crowdedness of housing from 1940 to 2000, with one line showing crowded with more than one person per room and the other showing severely crowded. Okay, and so notice how many severely crowded here, and it's really broken down here. Okay, so you get different types of information. Main thing is, can you read this? Okay, says the person you have 20% of the houses are crowded. At 1940, about 9% overcrowded, severely crowded. Notice the severely crowded goes down, and so does the overcrowded as we build more houses. All right, now choosing a data display. Okay, choosing the right display is not always easy, and maybe more than one choice that you can deal with. But to help you out, one, pictographs. If you want to use symbols, maybe for the younger ones, pictographs might be really good. Now remember, you can't do anything more than a half unless you do a circle and you do fourths. Okay, so you got to kind of be careful on how you want to describe your information. Dot plots. Okay, remember we talked about this to show frequencies. Stem and leaf plot used to show each value in the set data group of values into intervals. Okay, so you can get them in groups. In this case, you need to have them in, the ranges, 10 to 19, 20 to 29, that kind of idea. Okay. Bar graphs compare data items in group categories. You've seen bar graphs. They're not connected. They compare one thing different times maybe. Okay. Histogram, these are like bar graphs, but they're connected together. This is used to compare numbers of data items, typically grouped in numerical intervals ordered. So these have numerical intervals. Okay, now don't forget histograms, bar graphs, you can do doubles, right? Circle graphs to show the division of a whole. If you want to do parts. parts of a whole. Percentage bar, I don't use a whole lot of percentage bars. Line graph to show how things change over time, continuous data. Scatter plots to show the relationship between two variables. Okay, and that is it. The eText has some more stuff in it that's actually pretty good for you to go look at. Okay, notice I didn't even write a whole lot on any of these. All right, hope this helps, and you should be, with this being 10.3, to be able to do that next assignment. Okay, good luck.